So I have this very simple ColdFusion-rendered application which outputs a series of quotes. The quotes are just hard-coded nonsense. And I have previous and next links to go to the previous and next quote in this series. And you can see that there's no URL parameter here. So if I refresh, I'm currently on quote 7, quote 6, quote 5, 7, 6, 2. It's just randomly selecting a different quote every time I refresh the page with no query parameter. However, if I were to hit next, you can see now it's going to 3. If I hit next again, it's going to 4. And if we look at the network activity here and we look at all, what you'll see is that every time I hit next, I'm doing a full page refresh. I'm loading the JavaScript, the CSS, some additional JavaScript. And again, if we go previous, very similar. And if I use the browser back button, it does what it normally does. It's just pulling its rendered page out of the cache. So inspired by some post by Christopher and Andy, I wanted to see if I could take a portion of this page, namely just these quotes and the previous next, and wrap an AJAX'ifying boundary around that portion of the DOM tree such that I would intercept these clicks and implement this navigation in the background via fetch instead of doing a full page render. And let's just quickly take a look at the code to get some bearings here. So this is a ColdFusion application, meaning it's a server rendered application. And you can see at the beginning of every request, I have a request.quotes array. These are all of the arrays. Very uninteresting here. They're just numbered so that I can debug. On the main page, which is what we were just viewing, you can see that I have the option for a quote index. If it is not defined or it defaults to 0, then I'm going to be getting a random one. Otherwise, I'm just going to be getting the one as presented in the URL search parameter. And then I calculate the previous index and the next index. And then the rendering of this page is super simple. I just have my block quote here with the selected quote and my previous and next. And you can see all I'm doing is passing that quote index for the previous and the next. And right now we're just making server-side requests back to the server, again, to get this data. You can see I'm doing full page requests every single time. Now let's jump into the code here. I have this AJAX fragment. So what I want to do is make this block of code AJAX'ified, and I have the XXX here is to comment it out. I now have an AJAX fragment directive. This is an Alpine.js directive. And what it's going to do is it's going to listen for the click events bubbling up through the document object model. It's going to intercept those click events. It's going to make the request to the server using fetch. It's going to grab the element out of the returned content with this ID, and then it's just going to inner HTML replace all of this content. Now, actually, one more time before we look at this, let's just refresh. And notice that this timestamp is changing every time. 53, 52, 53, 56, 53, 57. And that's because, again, this whole page is refreshing. So now if we uncomment out this Alpine.js directive and we refresh, so we're getting the loaded code here, what you'll see is that when I go next, this timestamp isn't changing. 5508, 5508. In fact, the selection doesn't even get removed. But you can see that I'm cycling through 1, 2, 3. I can go back 3, 2, 1. I can go back in my history. I can go forward in my history. And you'll see that these are cache hits. We'll get into that in a minute, but you can see that this timestamp never changed. Of course, I could command click and open this in a new browser, and you'll see that with the timestamp changes there, and we'll get into that in a second. But for the most part, all of this is being done via AJAX in the background. So let's take a quick look at what's going on under the hood. So if we jump into the code here, and let's just look. So we have our AJAX fragment. This is defining the boundary around which this code is being changed. Internally, I have this lifecycle data binding. And if we jump down here to the bottom, you can see that this lifecycle data binding simply logs out the init and the destroyed lifecycle hooks. Those are going to be automatically called by Alpine.js. So even though we are never changing out this element because the overall page is never refreshing, we are going to be swapping this out, and we're going to see with this lifecycle logger that we're actually going to be changing the content and the bindings, the Alpine.js bindings, in real time. So when I click next here, you can see that it's a cache hit. It renders the page by destroying all of the content. So we log the destroy, and then placing in the new content or the cached content back into the active DOM. And at that point, we get the initialization of the new binding. And that's the binding that we see right here. So in fact, when I go to the next one, you'll see that this whole block changed, and it looks exactly the same at the element level, but of course the actual DOM reference has been swapped out, hence the life cycle here. All right, so let's take a look at how we're actually intercepting and implementing. And I'm not going to go through this in too much detail because I go through it in the code. I just wanted to demonstrate with a little bit more of a higher bird's eye view as to what's going on here. But we include this Alpine AJAX fragment, and that's the thing that defines my component here. And again, that's going to be specific to this element with this ID. And in fact, actually, as a funsies, what if we just copy this and we paste it and we do hot swap 2? Now what happens is we get 2 copies of this on the page. Of course, they're going to start off as being the same ID. But when I go to the next one, you'll see that this one has changed to 5, but this one remains 3. And if we look at the network activity, and let's actually just pop this over to the side here. If we look at the network activity, let's clear this. We look at the response, and we'll see that we get both the article with hot swap and the article with hot swap 2. And what's happening is that this AJAX fragment instance is looking specifically for this ID when replacing the content in the page. So it's actually completely ignoring this content. However, if I now do this one from 3 to 2, again, if we look at this, we'll see that we get the hot swap here, ID hot swap. This is quote 2, which is what we see in here. And this one, the second one here, hot swap 2, is also quote 2 because they're being driven by the same index. However, this quote 6 is never changed because it has a different hot swap ID. And this is a separate instance of this AJAX fragment. So they can operate independently. Of course, if we were to refresh the page now, both of these end up as 2. Anyway, it's just kind of a fun little example there of how these things can operate independently. All right, so let's just take a quick look at the AJAX fragment. And again, I'm not really going to go into much detail here because I go into more detail in the blog post itself. But this is the constructor for the AJAX fragment. And I store a handler here, and this is going to be identifying the state within the history API. This is the element ID, right? We just saw that each one of these is specific to an ID, an element with an ID, which is how they allow it to operate independently. And that is also going to be put in the push state. And we have some internal caching for our requests. We have an abort controller so that we only have one request operating at the same time. And then essentially what we do is we set up a click handler so that when the user clicks on one of these previous and next quotes, that's going to trigger a native click in the browser. That's going to bubble up. We're going to listen for it and override it. And then we're also going to bind to the pop state event on the history. And we're going to handle those back and forward buttons on the browser. I'll let you explore that in the code, but let's just go ahead and take a look at the click. And essentially, it's bubbling up through the DOM. We grab it. We see if it's modified. Modified meaning, did someone hold the shift or the control or the meta or the alt key? If it's modified, we want to ignore it, right? It's going to open up in a new browser tab or something to that effect, or it's going to be downloaded to the downloads. If it isn't modified, we get the anchor from the given event. That's the anchor tag that has the href. We make sure that it's not an external link, right? It's not linking to google.com or some other domain. If all of that passes, then we prevent the default, meaning we prevent the normal navigation event provided by anchor tags. We update the URL to mimic what the browser would have done normally, meaning we push that href value into the URL, and then we process the href. And by process the href, what I mean is we go and we fetch that href in the background, we cache the content, and then we render the content to the page. And I'm not going to jump around in the code. I'm going to let you explore that in the blog. It's all laid out step by step what we do. But anyway, I just think this was a fun thing to think about. There are other libraries that do exactly this. HTMX, Alpine has its own Alpine AJAX user land library. There's lots of things that do this, but I was inspired by Chris Ferdinandi's post on Ajax Form, and I like the idea of being able to just arbitrarily wrap a portion of the DOM and be able to progressively enhance it so it doesn't have to do full page requests.